All right, 9.2, angles in trigonometry. So an angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive x-axis. So that's like the right side. So that's right here, this one right there. Okay, the ray on the x-axis is called the initial side. The other ray is called the terminal side. And then counterclockwise rotations result in positive angle measures. Clockwise results in negative. And one full revolution is 360 degrees. Cool? So let's just get into drawing angles. The first thing I always want you to do is look and see if it's positive or it's negative. Well, A is positive because 75 is a positive number. So I'm going to start by labeling that 0. Then I'm going to go up 90 degrees. Go another 90, and that's 180. Go another 90, that's 270. Go another 90, and that's 360. Now, 75 lies between 0 and 90. And it's a little bit closer to 90, right? So I'm going to start my little line right there and then draw that out. That is my 75-degree angle. And make sure, I know my pen was like squiggly, it's because I had to do it on the computer, but you have to draw that little piece right there. Okay, now let's look at B. Is negative 160 positive or negative? Very obviously negative. So again, we're going to start with 0. But this time, instead of going up, I'm going to go down, and that's going to be negative 90. I'm going to go another 90, that's negative 180, another 90, negative 270, another 90, negative 360. Now, negative 160 is between negative 90 and negative 180, and it's closer to negative 180. So that's going to be right there. Draw that line, draw that terminal side, and you're done. Okay, let's do this last one. So 430 degrees, that is positive. So start with 0, 90, 180, 270, 360. We still haven't hit 400, and we need to get to 430. So let's just keep going. So 360 plus 90 is 450. And I can stop right there, because 430 is between 360 and 450. So I'm going to go around one whole time, plus a little bit more into that first quadrant, and draw that angle right there. Okay? So, radians versus degrees. Basically, radians and degrees are very similar. And you can kind of compare them to like how there's 60 minutes and 1 hour. Well, there's 180 degrees for 1 pi radian. Okay? Or you can compare it to like there's 60 seconds in a minute. Or there's 12 inches in a foot. Or there's 3 feet in a yard. Or any of those, that's the same things with radians and degrees. They measure the same exact thing, they're just different types of measurement. Okay? So 180 degrees is pi radians, which means 360 degrees is 2 pi radians. And we need to be able to convert back and forth to this. So if we're converting from degrees to radians, we want to get that pi into our answer. So we're going to multiply by pi over 180. If you're converting from radians to degrees, we want the pi to cancel. So you multiply by pi over 180 so that those pi's end up canceling. Okay, let's look at A. So I'm going from degrees to radians. So I'm going to do 30 times pi over 180. Put that over 1 and then multiply straight across. So that's 30 pi divided by 180. Well, 10 goes into 30 and 180, so that reduces to 3 pi over 18. 3 goes into 3 one time. 3 goes into 18 6 times, so that reduces to pi over 6. Okay, this is really just reducing fractions Hopefully you can remember how to reduce a fraction. Okay, let's look at B. So we have 150 times pi over 180. Put that over 1. Multiply straight across. So we have 150 pi over 180. 10 goes into both of those, so that reduces to 15 pi over 18. 3 goes into 15 5 times. 3 goes into 18 6 times. So 150 degrees is 5 pi over 6 radians. Now we have negative 220. Keep the negative. So we have negative 220 times pi over 180. Put that over 1, multiply straight across. That's negative 220 pi over 180. 10 goes into both of those, so that becomes 22 pi over 18. Then 2 goes into 22 11 times. 2 goes into 18 9 times. So that's negative 11 pi over 9. Okay, now I'm going from radians to degrees. So I'm going to take that 4 pi thirds and multiply by pi over, or 180 over pi. Because I want my pi's to cancel, so I need that pi to be in the denominator. So I have 4 pi times 180 over 3 times pi. Those pi's, I'm just going to rearrange that. So that's 4 times 180 times pi over 3 times pi. Those pi's cancel. I'm left with 4 times 180 divided by 3. You can put that in your calculator if you want, or 3 goes into 186 times. Then 4 times 60, or 60 times, not 6, is 240. So that's 240 degrees. Okay, let's do B. So that's negative 5 pi over 36 times 180 pi. Multiply straight across. Just going to rearrange that a little bit. Those pi's cancel. And then I have 5 times 180 divided by 360. If you need to, just put it in your calculator. But I know that 36 goes into 180 5 times. And then 5 times 5 is 25. So that is negative 25 degrees. Okay, this last one, 7 pi over 4 times 180 over pi. Multiply straight across, those pi's cancel. 4 goes into 180 45 times. 7 times 45 is 315. Okay. Now, coterminal angles. So coterminal angles are angles that have the same terminal side. So they stop at the same side. So I have to give 2 coterminal angles for each angle. One positive, one negative. So I'm going to do 65 minus 360, 65 plus 360. Because a full rotation is 360, so I just have to add a full rotation or subtract a full rotation. So I have 65 minus 360 is negative 295. 65 plus 360 is 425. Okay. Now 540, I'm going to subtract 360 first because it's positive, so let's just subtract first and see if I can get the negative one. So that's 540 minus 360 is 180. That's still a positive one, so I'm going to take that positive coterminal angle right there, and I'm going to subtract 360 again. So I have 180 minus 360, and I get negative 180, and I'm given both of those. Okay? First C. So remember that 360 corresponds with 2 pi radians. So I'm just going to subtract 2 pi from 13 pi over 18. And I'm going to put that over 1. Remember, when we're subtracting fractions or adding fractions, you have to get a common denominator. So I'm going to multiply top and bottom by 18 because 18 is my common denominator. So that becomes 13 pi over 18 minus 36 pi over 18. Well, 13 pi minus 36 pi is negative 23 pi, and then the 18 stays. So that's negative 23 pi over 18. Now let's add 2 pi. Put that over 1. Multiply top and bottom by 18 to get a common denominator. So that's 13 pi over 18 plus 36 pi over 18, which is 49 pi over 18. Okay, now D, let's start again. So I'm going to have 14 pi over 9 minus 2 pi. Put that over 1. Now my common denominator is 9. So I'm going to multiply top and bottom by 9. And I get 18 pi over 9. So 14 pi minus 18 pi is negative 4 pi over 9. Then D, put that over 1. Now we're adding, so multiply by 9 over 9 again. So you get 14 pi over 9 plus 18 pi over 9. 14 pi plus 18 pi is 32 pi over 9. Okay. Trig, 1 second. Whoops. Pause. Okay, sorry. I skipped this part in your notes, so we're just going to hurry and do it. So a reference angle is the positive acute angle formed with the terminal side and the x-axis. So let's just look at this example A right here. So this is x, this is y, and they're at 225 degrees. Okay, so let's just draw this first. This is 0, this is 90, 180, 270, 360. So 225 is between 180 and 270. So I'm just going to draw this. I'll switch colors. So I'm going to draw this right there. Then I'm going to make a triangle with the x-axis, and it's this angle right there. Okay, and you always work with 360 and 180. So 225 is bigger than 180, so I'm going to subtract that 180. So that'll be 225 minus 180, which equals 45 degrees. That is my reference angle right there. Okay, let's look at the next one. So we have negative 310. For reference angles, we can draw this using just like 0, negative 90. But let's find the coterminal angle to this. So I'm going to add 360 to get this positive angle here. So negative 310 plus 360 is 50. So this is 0, this is 90, 180, 270, 360. I'm going to draw that 50-degree angle right there. Make a triangle with that. That's my reference angle right there. And this is in the first quadrant. So 50 degrees just stays, because that angle is 50 degrees. We drew it. We know what this angle is. That's 50 degrees. If it's in the first quadrant, you just keep the angle. Okay? Let's do this last example. So now we have 2 pi over 3 radians. I'm going to multiply by 180 over pi to convert to degrees. These pi's cancel. I'm left with 360 over 3, which equals 120. So I'm just going to draw that. This is 0, 90, 180, 270, 360. 120 is about right there. Draw this down. That's my angle. Now, 120 is less than 180, so I'm going to do 180 minus 120, and you get 60 degrees. Is that reference angle right there. Okay. Let's go back to this now. Okay, so that's reference angles. Now let's do trig functions. So if we're given this little thing over here, this is theta inside. Theta is always inside. You always use that reference angle that's inside. Okay, we can use the Pythagorean theorem here, and that's just going to be x squared plus y squared equals r squared, because it's usually a squared plus b squared equals c squared. X is a, y is b, r is c. So sine is opposite over hypotenuse. Oh, let's label all our sides. Opposite, adjacent, hypotenuse. So sine is opposite over hypotenuse, which is y over r. cosine is adjacent over hypotenuse, which is x over r. Tangent is opposite over adjacent, which is y over x. Now, cosecant, you just flip sine, so that's r over y. Secant, you flip cosine, so that's r over x. Tangent, cotangent, you flip tangent. That's x over y. Okay, we're going to use that down in this bottom one. So we're given the point 5, negative 2. So let's just graph that. So that's 5 on the x-axis, down 2. So that's that point right there. Let's draw our angle, make our little triangle. That length right there is 5. That length right there is negative 2. I need to use Pythagorean theorem to find that missing length. So that's a squared plus b squared equals c squared. A is 5, b is negative 2. We don't know c, so that's 25 plus 4 equals c squared, which is 29 equals c squared. So c equals the square root of 29. Now sine is, there's my theta, label side, sorry, I'm getting ahead of myself. Theta is always that inside with the x-axis. So sine is opposite over hypotenuse, which is negative 2 over the square root of 29. Rationalize that denominator, multiply by the square root of 29 over the square root of 29. Negative 2 times the square root of 29 is negative 2 square root of 29. Square root of 29 times the square root of 29 is 29. Now cosine is adjacent over hypotenuse. So that's 5 over the square root of 29. Again, multiply by the square root of 29 over the square root of 29. And you get 5 square roots of 29 over 29. Tangent is opposite over adjacent, so that's negative 2 over 5. Now cosecant, we're just going to flip sine, and we're going to flip the very first thing I wrote down for sine. So that's going to be negative square roots of 29 over 2. Secant's the opposite of cosine, so I'm just going to flip the first thing I wrote down for cosine. So that's the square root of 29 over 5. Cotangent is the opposite of tangent. Flip that. That's negative 5 over 2. Okay, again, I'm so sorry for the length of this. I will make it up to you. See you guys tomorrow.